All right, we're going to graph this one afterwards because I want to know what it looks like. I feel like it's going to be, I mean, we know it's rational, but you'll notice the bottom is not factorable. It's the sum of squares. And if we look at the degrees of our numerator and denominator, they're the same. So we're going to have a horizontal asymptote at 1. So my sort of belief is that probably maybe the graph of this looks something like that, but I don't really know. Doesn't have any vertical asymptote, it just has that horizontal asymptote at y is equal to, oh, at 1. So pretend that this is happening at 1. You can like move it down. Bloop, 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 bloop. Here, I'll move my axes down. Whoop. Cool. And I'll put in that asymptote. So there she is. Anyways, let's see. I have no idea. We know if we're going to use that first derivative test, we need a first derivative, and annoyingly, they've given us k. So we need to go find k prime. Even more annoyingly, we have a quotient. Yeah, so quotient rule. Low d high minus high d low all over low low. All right, I just want to take a moment to say it is super important to have these parentheses here on that first term. Anytime your low or your d high or d low or your high has more than one term, we need parentheses so that the multiplication, the communication here is that it's happening to both terms, right? These two things are being multiplied together, not just the last term of that first piece. So let's go ahead and do some algebra, make this beautiful. It looks like we have 2x cubed plus 2x minus 2x cubed. Oh, that's nice of them. This is all over x squared plus 1 squared. So now we have 2x all over this x squared plus 1 squared. Now, we know we're looking for critical values, which could happen when our numerator is equal to 0, which 2x is equal to 0 means that x is equal to 0, or if our denominator is equal to 0. But as we noted earlier, x squared plus 1 will never equal 0. If you take the time to set that up, you hopefully get here, and then recognize once you take that square root, nothing good is going to come of it. So that piece will never be 0. We only have a single critical value at x is equal to 0. And now we need to make our sign table so we can determine if this is a minimum or maximum, or maybe it's nothing at all because there's no sign change. There's got to be a sign change for me to approach that horizontal asymptote at 1, but that's neither here nor there. So let's go ahead. We make our table. Boop, boop. X is equal to 0. This is the point that we're checking in on. Now this particular graph, whoa. Yeah, I was like, I almost got distracted by the graph I drew. I could, this is going to be a pain. I'm gonna plug in values. I'm just gonna plug in values. Okay, let's see it. So if I plug in a -1 to this function over here, my k prime, right? Don't get distracted by k. That's what I almost did. We end up with a negative over, so anything squared is positive. So negative divided by a negative by a positive is negative. Okay? If I plug in x is equal to +1, I'll have +2, which is positive, over that still bottom is positive. So we end up with a positive over here. Right? We don't really care about the magnitude of these things. We just want to know if they're positive or negative. So sort of collecting positives and negatives is good enough if you're in test case land. So at 0, we went from decreasing to increasing. So we have a relative minimum, which means my sketch, my guess, was off. We have a relative min at x is equal to 0 because k prime went from negative to positive. All right, let's go look at this graph because I'm curious. Boom. X squared, ooh, I'm not writing, x squared divided by x squared plus 1. It does the exact opposite of what I expected. Look at that. She cute. But like I said, we're approaching that horizontal asymptote of 1. We have that dip, which I guess I should have expected? 0 divided, yeah, I should have expected that. If I had just done a little bit more work in my sketch and plugged in like 0 to figure out where my y-intercept was, I would have had 0 divided by 1, which is 0. And so I would have realized that my graph has to come down and hit this value here at 0. And, oh, it says finding relative extrema. I should be even better here. I should write of 0 at x is equal to 0, right? So we should figure out what the actual value is if it asked me to find the extrema and not just say where they were. So we have that relative minimum of 0 at x is equal to 0 because our first derivative went from decreasing to increasing.